Alright, so I want to be able to explain this topic, and this is topic 7, finding limits of multivariable functions. I want to be able to explain it in a way that's understandable. Okay. So I wrote some notes here. I said to find the limit, check if direct substitution and factoring work. So just how we do with every other limit, we check if those work, because if they work, then we don't have to go any further. We don't have to take any more steps, right? But if they don't, if neither can be applied, approach from different directions. So basically, I'm going to show you a picture, or yeah, like an illustration of what that means. You probably already seen this when you were studying it, but let's just reiterate. So you got your graph over here. When you say that you're approaching, this is the limit, right? You're trying to approach it from different directions. When you say that you're approaching from the x-axis, that's this. You're approaching from the x-axis, your y is always equal to 0. So that's your condition, right? And you're going to write it in a way that you got a variable over here, you got the opposite variable over here, right? So because you got a y equals here, you got the x approaching 0 over there, right? And then we take a look at this one too. Same concept. That's going along the x-axis. When you're along the x-axis, your x is always equal to 0. That's that, right? And because you got x over there, x equals, then you got y approaching 0 over there. Okay, now we've illustrated it. Let's go back here. So I've written a couple of the most common directions to approach from when given the limit xy approaching 0, 0, right? Obviously there are a lot of, like, many different, so many different ways to approach the limit, but these are the ones that, once you get a problem, you want to try these right away. Okay, so you got number 1 over here. That, and number 2, those are the ones that I just mentioned. And you also got along y equals x, and again with the pattern, right? Along y squared equals x, right? And then you got x equals y, and then x squared equals y. Same pattern, right? And then I put a little note here that, oh shoot. Okay, put a little note here that this value right here, so you got y equals 0, right? This 0 is what you're substituting for y into a limit. So let's use this example over here to show that. This example, the limit as the limit of xy as it approaches 0, 0, and you got this, so obviously no direct substitution can't really be factored. Now you start approaching from the x-axis. So you got y equals 0 and x approaches 0. You substitute this into this. That's why I only got x squared over x squared, and that's equal to 1. And then I do the same thing with this. I substitute this into these, right? And then you get 0. So because these limits are different, then the limit does not exist, as we know. And all right, so now we got another example. Okay, right, so now we got another example, and I did the same thing, right? Just substituted that with that. Don't trip up with the exponents. Make sure that you're still putting the exponents in. You're only substituting for y, but this is y to the 4th, so this is really 0 to the 4th, right? So I'm mentioning that because here you do that thing where you substitute. So I'm using y equals x, and you're substituting x into the thing. So you got x squared up there, and then you got an x to the 4th over there. Okay, so you got 0 here, and you got 0 here. But for this one, you got a limit of 1/2. So it's different. Limit does not exist. All right. So these methods, this trial and error method, is not always the most efficient way to prove like that you don't have a limit, like the limit does not exist. Not always the most efficient way, because sometimes you're going to keep getting 0, 0, 0, 0, and you're going to be there forever. Like, you're going to stay there forever writing 0, 0, 0, and so you don't want to do that. You're going to have to find another way to actually prove that the limit does not exist. right? And that is the squeeze theorem. I don't know how savvy you are with the squeeze theorem, but personally I just learned this today, like 10 minutes ago, before I recorded this video. But now I'm gonna pass it on. Trina sent a video to the group chat, and that was a video that helped me, honestly. If you want to watch that, so like go ahead, because it's a very helpful video, but I'm still gonna try to explain it the best that I could. Okay, so we got here this example, right? Obviously, again, direct substitution is a no, and factoring is a no. And if you try to do the trial and error method, you're gonna be there trial and erroring forever. So we're gonna have to do like some more thinking with this, and we gotta be smart with it. So we gotta write down conditions. That's the first thing. We gotta write down conditions. And the first condition just so happens to be that this denominator can't be equal to 0, right? So it always has to be greater than 0. So you got you got this condition right here, right? Greater than or equal to 0. Well, okay. LOL. Okay, well, I guess that's something that I still have to understand a little bit more, but maybe that's kind of intuitive for you. I don't know how intuitive it is, but I kind of made sense to me, right? But okay, we're gonna say that x squared plus y squared is greater than or equal to 0. Okay, all right, sure. Then we know that x squared is less than or equal to this right here, that this is greater than this, right? And we write this because we realize that this up here we can rewrite as that. And so because you got an x squared over there, you're kind of starting to realize that, oh, if you divide this to all sides, right, you get this. And this looks very similar to that, right? But you don't want this. You want this. But all you got to do to get this is to multiply this to all of this, right? All right. So that sounds like, I don't know, it sounds like I was having a stroke, but it makes sense, right? So you got a 0 over here, and then you got this now, and this is what you wanted, right? And then you got this, because this times this equals this. And I color-coded it because I want you to see that we're taking the limit of the left and right sides first, because that's how the squeeze theorem is, right? So the limit of 0 is just 0, and then the limit of this is also 0. So it makes a lot of sense to say that the middle one, because of the squeeze theorem, is also equal to 0. All right, so I hope that makes sense. I promise the dude's video that Trina sent is 100 times better than this, but I hope this helped anyway. Okay,